I have to admit I'm old, and the title is of a comparatively old movie. Anybody old enough to know that the original thing? Yes. Awesome movie if you are into this kind of thing. So what I'm trying to do today is show you that, at least to my understanding, we're doing a lot of things wrong, despite we just learned, in case anybody was still here in this room for the ref presentation, that containers can be awesome. And maybe there's not really a problem in getting too big containers into production, but having them smaller, since, like, at least to me, feels like it makes a lot of sense. So I've been struggling with container sizes for quite a bit. In particular, given that I'm a consultant, I have a tendency to see projects that have some sort of issues, because I guess it's like when you're a doctor, everybody around you is sick, so the world must be existing out of sick people. So as a consultant, you usually see problems because people come to you with a problem, and you're like, okay, let's have a look at how we can fix that. And one of the things that I commonly see is people trying to make any kind of change in their software, and then, if they already have that, have a nice build pipeline that takes off and does stuff. And then people wait for like 10, 15, 20 minutes to actually get stuff done, because they have to build a new container and has to download whatever extensions and compile all those things, and it just takes forever. And I think that's annoying. And then it goes into production, and you see sometimes that they just take the container they just created and then just push it into a production environment if they use containers there. And that's basically the same image, which in one way is good, because that's what you exactly want. You want to develop and test as closely related to the real production environment. But those containers that you used for developing are not necessarily optimized for that kind of thing. So let's see how that could look like and why that might be a problem. And I'm not trying to bitch about this particular project. It's just like an awesome example. And if you can see, this is the comparatively old version of Dockware, which is a Dockerized version of Shopware. And you can potentially see that there's a, roughly 1 gigabyte in size image. And I don't know about you, but how large can Shopware as an application be? Okay, well, let's see if we can get an idea for that. We know that there's an Nginx in there. And in this 1 gigabyte, obviously, if we would assume that there's no redundancies, it's like, 50 to 60 megabytes of that might be Nginx. Again, that of course includes half of the operating system as a redundancy, but let's just ignore that for now. So from the 960, we have 900 megabytes left. So we know if we can get even smaller, let's say we take Albine, then that's 15 megabytes. So actually, we have more than, but okay. If we get even smaller, like more stable things, they could even be smaller, so maybe down at 9 megabytes. So you can shrink things a lot, but so the web server cannot necessarily be the problem, right? I mean, this is really small. So let's take PHP. If we take PHP in its most fat form, then that's a FPM Debian-based something that's, 150, 160-ish megabytes, and the Alpine version between, 30 megabytes. So assuming we can just extract that, so we have 800 megabytes left for Shopware, and what else might be required. So we might need MySQL or whatever kind of database, but that's the same kind of thing. So Shopware must be gigantic, because obviously it's like at least 600 megabytes in size. Well, probably not, but what we keep forgetting when we discuss these numbers is that the numbers listed here show the compressed size. So that's not even the actual file size if you expect it on your system. So if you would download it, that version would actually translate to 3.34 gigabytes in storage space for the whole Shopware container. If I take the standard PHP images, that's 458 megabytes for the Debian-based standard kind of thing, or roughly 75, 80 megabytes for the Alpine version. That's huge. And I'm not really happy with these sizes, because I mean, we're talking about web applications, right? And if we compress our PHP source code for excluding potentially assets that might be big because of many images, we might end up with a couple of kilobytes, maybe a few, 2, 3, 4 megabytes in PHP source code. So can't be that the rest of the environment is so fat. So why is that? Well, in case you never actually paid attention to the details why containers are the way they are, and quite many people already said containers are technically a lie. The thing is, it's not the container image. The concept of an image doesn't even actually exist. What a container is, or the container image, is basically a metadata file that refers to various layers, which are individual tar or tar gzip files that you can download. And they are stacked into individual things so that they, at the end, when being applied, all in the correct order, they present the file system as the application sees it. Which has an interesting side effect, because if you see how you can download all these individual things, they have individual sizes, of course, you end up with a system where something that created the individual layers, or there need to be a process to create the individual layers, which usually is doing this Docker build, whatever, from the container file or the Docker file. And every line in that file represents one layer. Which leads to an interesting side effect that if you create something in one step, and it creates intermediate data files, and then you go to the next step, and you delete those things because you made the first line, basically, for example, compile it, and then make a new line in the Docker file and say, now make install or whatever, then everything that was temporarily being created is stored in the previous layer, even though the next layer might remove it. So in the final file system, you're going to see a lot less, even though in the layers it used to be there. So there's some tricks involved to actually fix that, and we're going to see how that looks like in a minute. But if we were to actually understand what actually these layers logically mean, there's various interesting tooling around to actually browse what the layers are made of and what actually changes, so you can just see that. Because if you remember the downloading thing here, this is just hashes being shown. So that's really like whatever it's downloading, it's just some arbitrary artifact. And you sometimes may wonder, like, why are there so many? Well, that depends on how many build steps you basically had in the container file. So if you want to see how that looks like, there's a very nice tool called Dive. Anybody in here using Dive already? Yes, a few hands go up. Nice. In case you didn't know it, it's an open source tool that you can just download, and it provides a nice view on what your container is actually about. And let's just make that into full screen. So in this case, it's a custom-built container image that I create here. So that's why there's not really much information on what the individual layer is used when being created. But you can see that each thing has its own representation. So this is the core thing, that's the base file tree as it's being created on the original first layer. Then comes a layer on top, and everything that's green is being added by that layer. And if you continue, you can see that there's additional things being added and additional things being added. And with that, the whole thing grows over time. So that's really helpful to actually have a view on what is in this particular container image and how it's being assembled. So if we want to do this, we can also, of course, do that with the standard PHP FPM example that I used before and see exactly the same thing. But that's boring theory, right? We want to shrink things, so we want to do stuff. And I mean, we're in a cinema, and it's very comfy seats, I get that. So let's try to do something and try to shrink something. And, well, I need an example on how to do that, and to get my hands dirty myself and trying to understand how I can actually get a cool container, I had to look to my own tools. So together with a friend some years ago, we created a small application called Five, in case anybody in here knows that. Yes, a few people do. Nice. That's used to install far archives, because I figured, or we as the team when starting developing it, that maybe it's not necessarily the smartest thing to combine runtime dependencies that you can manage perfectly using Composer with like tooling requirements. Because if my tool needs the library in a certain version and my runtime needs the same library but in a different version, I already have a conflict. And to not have that, or if I have different tools requiring different versions, I also can't manage that. So vars are basically the jar files, in case you never use them, for the PHP world. So you can basically package your application and then just run it using PHP, but every dependency is included in that. So, but managing all these things and having the latest version and having it verify that the signals are matched when installing it and all that stuff is annoying. So we created 5. And people were like, hey, we need a container image where this is included. And I was like, no, why? It's a tool, it just works. Up to the point where I had to do something for a client in CI pipeline where we needed images to run this stuff on. And suddenly like, okay, how do I get 5 to be executed in this container without having a container myself? And I was annoyed, and then I figured, actually I can open myself a ticket that I can create a container image, just to realize I already had one for years. Yeah, so I decided to build a container. And, well, I created the most simple thing that I could possibly imagine what to do. So I'm using Fedora Linux on my desktop, or on the laptop. So I figured, let's just use that one. And, well, give it a nice name so I know what it's about, and install the dependencies that I know that I'm going to be needing so 5 can operate. And then just copy the created var archive into it, make some small internal changes, and happy. Well, running this, it does like all the individual steps, blah, 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 happens, stuff happens. And just to give you a reference, the var archive itself is 15 kilobytes. Almost. Ouchin. So, what did I do wrong? Well, I ignored the rule that I actually knew that existed, and I just explained it to you. Every single line here is a layer. And this line here installs the required packages, which is cool. But to do so, DNF downloads a tremendous amount of data to figure out what the dependencies of these individual things are and what also needs to get installed along with that. Except that I don't need that information once it's installed. But it's part of that particular layer now. So the fix is, well, let's skip that part. The fix is to actually clean up. So in this case, I just had to add the double times ampersand DNF clean all to get rid of all the crap that this thing installed along that I don't need. And these adding it and chaining the individual things, sometimes even with like line breaks and the nicely escaping of the line break, is what people do. And so you see that run, and then you have like, I don't know how many lines of things. This is exactly the trick that's being used to ensure that everything stays within one layer, and by the time all the processing is completed, this layer is as small as it can possibly be. That sounds like a really good start, and it basically cut this thing in half. That's already pretty impressive, but 250 megabytes for a small PHP thing with a few extensions and like GPG as a binary? I mean, seriously? So this is not what I want to go. I want to have a small container, right? We want to shrink things. So what can we do? And I figured, well, maybe it's because I started with an existing distribution. So getting a smaller container means that I have to maybe do something from scratch in a way. But I didn't want to compile PHP and all these things myself. So there's a cool option. There's DNF install root. So if you're using Fedora or any Red Hat Linux distribution and they use DNF, you can specify a custom directory where the packages should get installed. And if this directory is empty, well, then there's assumed that there's no package already there. So if there's any dependency, it will just install everything there, but it will keep all the caching information somewhere else. So that's cool, because you're basically using your own local system to just create an empty directory structure. So basically, it's change root on steroids, what you're operating on here. So that's cool, except if you do this, the final image is even bigger than before. OK, fail. OK, so maybe I need a different approach. And then I remembered, luckily, PHP is built basically based on C or C++. And there's a nice tool if you ever compile things yourself. You have maybe an idea that there's a binary being created, and everything that you're linking in from others are shared libraries, so SO files, at least in the Linux world. And the tool LDD, which basically passes, well, I'm simplifying a little bit, the meta information of the binary, where it says, OK, I need these additional libraries to actually operate. So if any of these SO files would be missing, you can't start the application and will bitch about, like, hey, I'm missing this whatever SO files, so I can't operate. So that sounds like awesome idea, because I could take the PHP binary and simply LDD it and figure out what kind of extensions or SO files I might be needing. The cool thing is that is done recursively, because if that needs an SO, that by itself needs an SO, it also gets listed, because that happens as in one block. So we need to apply this recursively, and we need to do this for every SO file that we would be manually loading, because what PHP is doing with the ini files, you're going to specify an extension equals whatever. So it's going to be an SO that's not hard linked to the application, but it's something that's loaded at runtime. So we need to have an idea of what extensions we're going to be needing and what SO files are required to actually make those extensions become available. That sounds cool. So I started doing this, and I created some test scripts and like some shell scripting, and it didn't feel like perfect, but I felt like I was on the right track. And then I figured, OK, now that I know what the individual things are, I have a list of files that I need to copy, and I have their locations, so I can create a shell script that just copies that into the new directory structure, but that's just a folder. I need to get this directory into a container. And I'm not the biggest fan of Docker as a tool, but the idea of containers and OCI containers in particular is really awesome. So I was looking at alternatives on how to create my container image, because I didn't want to create a Docker file and use build, because that doesn't make sense. There's a directory, and I don't want to copy that. It felt weird. So I was like looking what alternatives there are, and there's a tool called Builder, which I recently learned is named that way because if you're from Boston, this is like what Builder would be pronounced. And I always wondered who came up with that name. But yeah, apparently Dan Walsh, who invented that thing, comes from Boston, and he was like pronouncing it that way, so the people writing it the first time wrote it that way. I don't know if that's a true story, but they told me. Either way, this has a different API-driven approach on creating your image. So you basically can tell it, like, add this file, add these files, add this directory, and just tell it to do this. And while I managed to create something that contained layers and had data in there, it didn't work. And I was annoyed. And I talked to a friend, and that friend told me, like, hey, you know, why are you reinventing the wheel? That exists. So I was like, OK, open source for the win. So let's see if we have internet here. Well, it's going to take a bit to load, apparently. Yeah, let's see if it actually loads at some point. So this is an open source shell script, basically. And yeah, you can see it's already starting to load, and it's really, really small. There's only one problem, and by the time it fully loaded, you might actually see that. A, there's no official releases, and you will see that the last update, when this part here is finally done loading, is comparatively long ago. And usually that's like, do I really want to use that? But then if you look at what the script is actually doing and how long it is, you're like, well, this is not worse than my shell script, and that's only like a few lines anyway. So if there's any problem, I might be actually able to, well, fix that potentially myself. And yeah, I guess we're gonna wait for this to finish loading. So we're just gonna go back to the presentation. So what this thing is basically doing is providing you a small CLI or shell script where you can tell, like, hey, I wanna have this base image being used, and I wanna tag it, in this case with 5. And I want you to actually include an additional container file, which in that case adds the entry point and command things the way I want it. I want to have a package included, so I make sure that this is still there. And otherwise, please add all these files. And then this thing does some magic. And under the hood does exactly what I was trying to replicate, is using LDD on all the individual files. It's going to use the package database to actually verify that this particular package and all the files that are supposed to be in there because of that particular package are being copied. And, well, turns out if you do that, based on my originally 250-ish megabytes in size image, I get 40 megabytes. And that actually makes a lot of sense. Because if we were to dive into that now, let's see if that actually works. Probably should increase the thing. You can see it's shrunk into one single individual thing, because that's what the strip thing does. And you can see that there's obviously a shell, which is in this case a symbolic link to BusyBox. It has the INI files for curl, DOM, MB string for handling vars and for XML things. It has some TLS-related things so that I can use curl to actually connect to external things. You have a bunch of libraries that are dependencies of the things that we are using. And then there's a GPG binary, because we need that. There's PHP. There's which to find certain things, which even though in that case would not necessarily be required, but 29K is not necessarily a size worth optimizing, I think. And we have additional things like BZ2 and the SO files for that. And you have my local, okay, in this case it's 233 kilobytes in size. That's the far archive. And then we have, actually the majority of data is time zone infos, 106 megabytes. The PHP binary itself is not necessarily the smallest. I mean, from the 40 megabytes, PHP itself is 8.5. And turns out, if you look into that and skip all the ini files and just see like what modules are actually included, there's a bunch of stuff that comes compiled in if you take the RPMs from Fedora or from Remi, which I could probably strip out half of them, because in my use case, I don't need them. But that would require me to compile PHP myself, and I honestly was too lazy to do that. But in general, I think from like 400 something, being stupid, down to 250 to be a little bit smarter, to like 40 megabytes, is actually quite okay. What I don't necessarily like too much, though, in the end, is that, of course, this is shrunk down to one single layer. So that means that if I'm going to make any changes to that image, I have to download those 40 megabytes all over again. If you make changes a lot, and there's, for example, only the 5 part in, as in this particular file being different, then it probably would make sense to actually have a combination of build steps. So to say that you're going to create the PHP runtime kind of thing as the first thing, and make the local bin 5 thing a dedicated step after stripping it. so that you have 2 layers in that particular file in the end, so you do not have to download the PHP runtime environment all over again just because you created a new file. But in this case, this is supposed to be a release thing, so I didn't really bother too much about optimizing that anymore. Okay, how are we doing timing-wise? Yeah, that looks good. Ooh, bright light. Okay, so we are at 40 megabytes on real actual disk size. Well, we just did that. If we take a look on when we upload this to the Docker Hub, we are down to 15, because in the compressed form, this is what is actually left. And I think this is pretty okay. But we have, at least in many cases, we have a problem, or maybe we have one. Because many people say like, yeah, you know, what you created here is a complete different way of creating an image, but we are in a large enterprise and we have like this complex compliance kind of thing happening here, and we have to verify that everything is licensed properly, and we have to use SBOMs. Anybody here using SBOMs already? 1, 2. Okay, that's not that many. Okay, anybody here, like, I'll make it positively, who knows what an SBOM is? Okay, that's also not enough people. Okay, so I'm going to make a quick excursion to that. SBOM is an acronym and stands for Software Bill of Materials. And the basic idea is to replicate what everybody probably knows from like any kind of food product that you would potentially be buying into a supermarket. Because if you take any kind of food product, you can turn it around, and the back end it says like what's included. Those are the ingredients. And for a really long time, we didn't have that for software at all. So you just got a black box that hopefully did what you expected it to be doing, but nobody any idea of what component it was comprised of. Sometimes, if it's an end-user kind of product, you might have a hidden info screen somewhere where you basically have a concatenated list of licenses. Like this project uses this license, and we are legally required to add this. But still, then you know that this uses whatever kind of component, but you had no idea of what version. So not necessarily helpful, because every piece of software that you can combine to your product might contain a security problem. So how do I find out whether or not I have to update? Well, if the vendor releases an update, I know, but I don't know if I'm affected by a security problem unless the vendor tells me. That's not necessarily optimal. So from a supply chain security perspective, having a black box that is just a container where stuff is in is really not that nice. And it became worse over time because, particularly in larger enterprises, when containers started, they allowed to a kind of Wild West attitude. Because back in the beginning, you were happy to have a physical machine that was run by administrator and IT staff, and you were granted access to put your software on there as well. And then suddenly it was like, I don't want to talk to the admins anymore to get a whatever extension installed. I can do this myself by providing a container where it just happens to be running inside, and the admins only make sure that the physical box runs, and maybe the Docker engine or Podman or whatever is being updated accordingly. And now we have a lot of software running on those machines, and nobody has any idea what's included. So turns out sometimes presidents in the US have smart ideas. So some previous presidents decided to enforce that a standard that has been growing for quite some time is going to be enforced by law. So if you ever want to ship any piece of software that is supposed to be run by any government agency in the US, and more frequently and commonly now also in Europe, you have to provide an SBOM of your software, which implies that you have to list every piece of software that your piece of product contains of. So if you're going to create an image, which is based on any distribution, you have to add every information that you can get your hands on in SBOM structures about the operating system, about the PHP extensions and the dependencies that that one has, your PHP application dependencies, like your framework, whatever third-party libraries that you installed via Composer, and all these things. And you basically create a giant data structure which has, this is what the software is being made of. And if you have that, and you provide that in a technical form, as in machine-readable format, then you can have tooling installed in your enterprise or wherever that can analyze these things and can tell you, hey, you're running this version of that container, and that contains this library in that version, and that has this security flaw. And you might want to update this, because that's the latest version that is available. So this is really, really helpful. But most of these tools require you to have standard databases and mechanisms available to verify that. So you need a composer log file, for example, to analyze the composer dependencies, or you need the package database in the container to know what packages are installed and what versions they are. Well, turns out there are smarter tools these days, and one of them is called Zift. And with Zift, you basically point it to a container, and it has a lot of analyzers in place. And it can use what I just mentioned. It can do so for any other operating system and programming language as well. So if you have a Node application, it can understand the npm packages log files. It can do this for Python, for Ruby, all these kind of things. You have that for Debian, Alpine, Fedora, and whatnot. And you have a file database. So if it looks at a file, builds a hash, and then knows, OK, this file and this directory with this hash comes from this original package. So if you would run this, despite it being compressed into one single layer of simple files, having a somewhat recent version of Zift, it can tell you, like, hey, these are the original RPM packages that have been used to create this. Granted, not everything that this RPM might have originally contained is actually in that image, because I'm only copying the files that I actually care about. So if there's a man file or additional documentation, this is all not included. But with that, I have a nice way of actually understanding of what I'm doing here and what's included. And I can tell people, like, hey, you can use this particular image, and at least by the time of creation or when running this particular check, there are no known vulnerabilities in there, because all the versions of these things are actually currently up to date. And that's a lot more that you could have said with all kinds of other things. So if you were to do this on a standard thing, let me quickly check if I still have that image around. Whoop. Yes, I do. Awesome. Okay, that took a bit. So this is analyzing the thing. It had some issues getting to the network. Okay, has to be expected. So this is now analyzing, and you can probably guess by the time it took to analyze that, this is the huge image that I had from before. And it has 159 packages and 5,717 files with 41 executables. So that's the standard Fedora base image that I get, with like PHP and the things installed as I showed you before. And why this is so relevant is that you can probably imagine if you were to scan your image for security things or for updates, if you have 159 packages, chances are comparatively high that there is a security flaw and an update required for you to install. So there's more change in having this image being updated. If you do this for my smaller image, and now it's probably going to check for an updated version again, it's a lot less. So with that, the likelihood of me being required to actually create a new image is already reduced. And everything that's originally included in the previous default kind of image is also missing. So you can see I have 30 packages that are logically being affected. They're not even completely installed. So I think this is a lot better. And It also means if I'm, in this case, I actually have to install BusyBox or any kind of shell, and BusyBox is one of the smallest shells that you can get, to be able to call exec. Because if you want to do a external process to be started, you need a shell wrapper around that. Otherwise, PHP has interesting issues. Interesting, really, because I tried that without having the binary included, because I didn't know that it was required to actually include this. And you get there's out-of-memory errors. What? I was really confused, and I tried to okay, how do I give this process more memory? And no, nothing helped. So I started reading the C code of PHP on how exec is being called. And turns out there's a bunch of potential return codes when trying to do this, and there's a default out of memory. So if it doesn't know what it is, it's out of memory. Thank you, PHP. Okay, anecdotes aside, anything that could possibly go wrong in your application would potentially lead to a security problem. Any piece of software that is contained in that image can be abused and used against you. So if you have a container image which allows to install additional applications, which allows you to download different things, which allows you to compile things, is a tool that you provide to the attacker to make their life easier. And I don't think we need that. So I'm really happy that I found this way of shrinking down things. I actually created a new project, which is, well, not fully ready to be launched yet, which I'm calling Custom Container, which is allowing you to specify which extensions you're going to need, and it's going to build you that particular image, pretty much shrunk down to what I'm showing here. So if you remember the dive thing that I showed before, this is exactly what's actually being generated by Custom Container. It lists, or you specify by using the composer log file, what kind of extensions you need, and it's going to create your container image that only contains the extensions that you need and their dependencies. So depending on what kind of things you selected, you can see that there's on the upper side here a little bit, that there's curl, DOM, var, tokenizer, being requested in this particular example. And the total size of this image unpacked is 36 megabytes. So this is also the most condensed way of getting a container built. And the cool thing is that if you actually want to use that, it's an API call to our system when it's ready. And then basically you load the individual layers as needed, and you don't have to compile a container image anymore, compile extensions and whatnot. So that can be a lot faster and easier. So I guess I'm having a few minutes left for questions. Okay. Before we go to questions, I'm going to add a little bit of a commercial slide. We create all kinds of trainings as we are consultants. That's how we teach people. And I've been asked various times on how to secure. Okay, I cannot even type properly. So securely operating containerized applications. I'm working on getting this as an English version. I have a German version of that particular training online already. If you're interested in getting notified when this one is ready, feel free to just submit that form. We're just literally going to send you a mail, hey, this is about ready. If you feel like joining us, here are the details about it.